Okay, we're going to graph the function e to the power x, the most common exponential function, the one we're going to be dealing with a lot in Chapter 4. So e to the power x is defined for all values of x. Okay, I can always take a positive number and raise it to any power I want. So to graph this function, we just need to pick a couple of values for x and find the function value y that goes with it. So I'm just going to plug in some nice easy numbers here for x. So if we put 0 in for x, well, y would be e to the power 0, which is, of course, 1. You might remember any number to the power 0 is 1, so that means the point 0, 1 is on our graph here. Okay, so each little tick mark is 1 unit. If I put 1 in for x, I would get e to the power 1, which is just e. Okay, and that's about 2.72. Okay, so when x is 1, y is about 2.7, so we got a point right here on our graph. When x is 2, maybe do one more here in the positive direction, y would be e squared. Okay, well, that's probably not one you can do easily in your head, so you need to go to the calculator. And if you want to compute something like e squared on the calculator, basically this is what you need. You need to hit that second button on the top left corner, and then hit that button that says ln. You'll notice it's got this little e to the power x here. Okay, so if you hit second and ln on the calculator, you'll get something like this, e to the power in a parenthesis, and then just put the number here that you want to raise to the power base e. So you can type a 2, close the parenthesis, and press enter, and it will give you a decimal answer. Okay, so I did that on the calculator, and I'm getting about, let's see, it's about 7.39. Okay, so when x is 2, y is going to be, let's say, 7.39. It's about here somewhere. Okay, about midway between 7 and 8 units up. Okay, but we can actually put any number in we want for x. I just picked whole numbers because they're nice. I should probably also put in some negative numbers. If I put -1 in for x, okay, y is going to be e to the power -1, which is about 0.37, yeah, about 0.37. So when x is -1, y is about 0.37. So right about here we got a point on the graph. And let's do one more, -2. Okay, if x is -2, y is going to be e to the power -2, which again you need to find on the calculator, and I'm getting about, looks like 0.14. Okay, so when x is -2, y is just barely above the x-axis, about 0.15 units up. So I'm drawing it pretty close to the x-axis here. Okay. Well, in graphing by plotting points, that's kind of the theory there. Just plot enough points and then connect the dots, and basically we see a pretty clear pattern here. To the right, the function's getting very large and positive. To the left, it's actually flattening out, though. Okay, and if we were to keep plotting, we would continue to see that. Okay, so the basic shape of the function e to the x is something like this. Just worth mentioning here, the domain and the range. Okay, well, the domain of any exponential function is -infinity to infinity. Okay, which you can see from the graph, and of course we kind of know that based on the formula. X can be anything. The graph goes all the way to the left and all the way to the right. X can be any number. Okay, but the range refers to the y values on the graph, and y can be any number as long as it's positive. Okay, and if you see that, look at the graph for a minute, you can kind of see that. The graph can be a very small positive number to the left, a very large positive number to the right, but the y values can't be negative. There's no point on this graph that is below the x-axis, okay, or even on the x-axis for that matter. Okay, it flattens out to one side and grows very large to the other side. Okay, so that's pretty good. Now, just again, like anything else, we can graph this on the calculator, and if you type this one in on the calculator, I don't think you'll see much different, but maybe just worth mentioning, how you would, oops, fix that here, how you would do that. Just hit the y equals button, to get the equation editor, and then on the screen you'll see something like so. And just for that function y1, we don't need a y2 or y3 or anything. Just hit that, second ln button, put e to the power there, and then just type the x button, e to the power x. Okay, and then if you hit the graph button, you'll get the graph of e to the power x, which should look pretty close to the one that we just got here. Okay.